Welcome to EduDisc. Today's video, we are going to discuss one of the important topics, that is trigonometric ratios, and few questions from this particular topic. Now, this chapter, Introduction to Trigonometry, comes under the unit Trigonometry. There are two chapters under this unit, and if you check the chapters, they are Introduction to Trigonometry as well as some applications of trigonometry. The total weightage for these two chapters is 12 marks, and out of which, as per the new sample paper, if you see, around 8 marks is coming from this particular chapter, that is applications of trigonometry. So remaining 4 marks will be coming from the chapter Introduction to Trigonometry. So the main topics are trigonometric ratios of some specific angles, and trigonometric identities. As this particular topic, that is trigonometric ratios of complementary angles, this is deleted for the current academic year. So you need to learn the subtopics or the sections. Trigonometric ratios of some specific angles, and trigonometric identities. Now, let us take trigonometric ratios. How to write the trigonometric ratios and how do we remember the trigonometric ratios? So, if you take the trigonometric ratios we take for a right angle triangle. So, naming the sides of a right triangle. First thing is, if you have an acute angle in a right triangle, you need to know which side is the opposite side, which side is the adjacent side, and which side is the hypotenuse. Now, all of us know that which is the hypotenuse. Now, opposite side means the side opposite to the mentioned angle. So, like here, angle A is taken as the acute angle. So this is taken as theta. So the side opposite to theta, that is BC, should be considered as the opposite side. Similarly, AB should be considered as the adjacent side. And AC is the hypotenuse. So there are 3 sides and 3 angles in a triangle. So total 6 measurements are there. So there are 6 trigonometric ratios also. Each trigonometric ratio gives a connection between two sides with respect to one of the acute angles. So how do we write these trigonometric ratios, and what are these trigonometric ratios? They are sine. What is sine theta? Sine theta is opposite side divided by hypotenuse. Opposite side to theta divided by hypotenuse. Cosine, or we say it as cos. Cosine means cos only. Cos theta is adjacent side divided by hypotenuse, or the side adjacent to theta divided by hypotenuse. Tan theta or tangent is equal to opposite side divided by adjacent side. Remaining 3 trigonometric ratios out of these 6 are cosec, which is the reciprocal of sine. So cosec theta is equal to just the reciprocal of sine theta, that is opposite side divided by hypotenuse divided by opposite side. Sec theta will be the reciprocal of cos theta, that is hypotenuse divided by adjacent side. Cot theta is the reciprocal of tan theta, that is, here it is opposite by adjacent. So for cot, it will be adjacent side divided by opposite side. If we are taking this one, this figure, we know that already we have taken AC hypotenuse, BC opposite side, and AB the adjacent side. So how do we write the trigonometric ratios here? It will be like A is taken as angle theta. So sine theta will be equal to BC divided by, the opposite side is BC. BC divided by AC. Cos theta will be equal to adjacent side, that is AB divided by AC. tangent or tan theta is equal to opposite side, that is BC, divided by adjacent side, that is A. Now, as we know, the remaining trigonometric ratios are the reciprocals of these. So cosec theta is equal to 1 by sine theta, which is equal to AC by BC. Then sec theta is the reciprocal of cos theta, that is 1 by cos theta, which is AC divided by AB. And cot theta is the reciprocal of tan theta, that is 1 by tan theta, or you can write it as AB divided by BC. So this way we will be able to write the trigonometric ratio. So if these measurements are given, for example, if this is 3 centimeter, this is 4 centimeter, and this is 5 centimeter in a right triangle, then sine theta will be equal to 3 by 5, cos theta will be equal to 4 by 5, and tan theta will be equal to 3 by 4. Similarly, we will be able to write the other trigonometric ratios also. Now, how do we remember these trigonometric ratios? Already we have discussed there is an easy technique to remember these trigonometric ratios. That is, it is written in a particular form like SOH, CAH, and TOA. It is, you can say so, ka, and ta. So it is something like, if you take sine is equal to opposite divided by hypotenuse, OH. Cos is equal to adjacent divided by hypotenuse. And tan is equal to opposite divided by adjacent. Or you can even remember like this, son of Harry can always have tea or alcohol. Or son of Hitler can't always hide the old age. So it is any way you can do. Sine is O and cos is R. But if you know the values of sine and cos, it is very easy to write the values of tan, because tan ratio is sine divided by cos. So this way you can remember the trigonometric ratios. And once you know the trigonometric ratios, you will be able to solve the problems from this particular question. Let us check one of the problems. In triangle PQR, angle Q is 90 degrees. So it's a right triangle. And it is given that sine P is equal to 7 by 25. Find cos P and tan R. So these type of questions you will get from this particular section, and it may be sometimes like 3 cos P plus 5 tan R divided by 4 cosec P, something like that. But the only one thing is, like, once you know this sine P, then you will be able to write the sides of the triangle, 3 sides of the triangle you will be able to write. And after getting the sides of the triangle, you will be able to write any trigonometric ratio, because sine ratio or sine of an angle is opposite side divided by hypotenuse, and cos of an angle is the adjacent side divided by hypotenuse, and tan is sine theta by cos theta. So now sine P is equal to 7 by 25. So here P is this angle. So we have to write with respect to this angle only. Sine is opposite side divided by hypotenuse. So the opposite side is here QR. So this should be taken as 7 and this should be taken as 25. But because this is a ratio, 7 by 25 is a ratio, doesn't mean that always this will be 7 and this will be 25. So we will take this as some 7k or any letter, you can take 7m or 7x, anything. So 7k and this is 25k, so that the ratio will be always 7 by 25. Now the next thing is to find out this missing side. This missing side we can find out using Pythagoras theorem. Now what is Pythagoras theorem? It is hypotenuse square is equal to base square plus altitude square. So PR square is equal to PQ square plus QR square. So PQ square will be equal to PR square minus QR square. That is, K is a common thing. K square will be common. So 25 square, that is 625 minus 49. It will come as 625 minus 49. So you will get PQ square as 576K square and PQ will be equal to 24K. So we got all the three sides. Here it will come as, this side already we have taken this as 7K. This is 25K and this we got now as 24K. Once you know all the three angles, you will be able to write any trigonometric ratio. So whatever be the trigonometric ratio, we will be able to write. For example, if this angle we are writing, then cos will be equal to of the adjacent side, that is 24K divided by 25K. So cos P will be equal to 24 divided by 25. Sine is already given, sine P is already given, which is equal to 7 on 25. So tan P will be equal to, just divide these two, so you'll get it as 7 by 24. And cosec will be 25 by 7, sec P will be 25 by 24 and cot P will be 24 by 7. The same way, if you want for this angle, then the only one difference is this will be the taken as the opposite side and this will be taken as the adjacent side. So this will come as, sine of R will come as 24 by 25 and cos of R will come as 7 by 25, just vice versa. So we will be able to write all the trigonometric ratios. Once we know all the trigonometric ratios, it is very easy to solve any or find out the value of any thing given in the question. Just need to substitute the values of. Now another question. Here you can see another example. In triangle and ABC and triangle PQR, these are right triangles such that sine A is equal to sine P. Prove that angle A is equal to angle P. Now let us check the solution. How do we do it? Here these are the two triangles, right triangles. It is given that sine A is equal to sine P. Now sine of A, opposite side, that is BC divided by hypotenuse, that is AC. So BC by AC is equal to sine P, that is here QR divided by PR. So it is given that BC by AC equal to QR by PR. Just interchange this, take this AC to the side and QR down. So BC divided by QR is equal to AC divided by PR. We got like this. Let us take it as K. Let BC by QR equal to AC by PR is equal to K. So by cross multiplying, you will get BC is equal to K into QR. Similarly, AC is equal to cross multiply. So K into PR. Then find out the ratio AB by PQ. What is AB? AB square is equal to AC square minus BC square. So AB will be root of that. AB is root of AC square minus BC square. Similarly, PQ square will be PR square minus QR square. So it will be PQ will be root of PR square minus QR square. So we got like this. Now substitute for this AC and BC. So AC square will come as K square PR square here minus K square QR square. So K square is common. K square into PR square minus QR square. Root of K square is K. So it will come outside and remaining is root PR square minus QR square divided by root PR square minus QR square. Cancel out and we get it as K. So you can check here AB by PQ. After doing this calculation, we got it as K. Already we have taken BC by QR and AC by PR as K. So all the three are equal. That is AB by PQ equal to BC by QR equal to AC by PR. Which means we can say that the triangles are similar by SSS similarity criterion. So triangle ABC similar to triangle PQR by SSS similarity criterion. If the triangles are similar, then the corresponding angles will be equal. Corresponding angles of two similar triangles are always equal. So this way we can solve. These are two different types. So one is this type and one is the other type that we have discussed, that if any one trigonometric ratio is given, then we will be able to find out the other trigonometric ratios, and then using that or substituting these values, we will be able to solve any type of question coming from this particular section. So hope you have understood this. So the next session, we will take trigonometric ratios for some specific angles. How do we remember these values and how to substitute these values and what type of questions you will get from there. Thank you.